Welcome everybody who is here in the web seminar today. The following points that we will go through is first a product presentation, then I will show a live demo of SweepMe. We can follow in the following do a Q&A session where you can ask questions about your setups or things how they are done in SweepMe. And at the end, I will also go a few minutes into SweepMe Pro and what you can do with it. So whenever you have questions, just put them into the chat and Martin can bring them into the discussion. So I will share my screen. You should now be able to see my screen, and I will start with the presentation. So the basic idea of SweepMe when we started several years ago to create it was to combine instruments from different vendors very quickly. The problem was that at the institute where we developed SweepMe, everybody was writing own individual software at each setup, but still people had the same equipment, for example, the same source measuring units, but everybody had own code, and this was not really that you could share your contents. So the idea was, why is it not possible to make a software where you can share contents for each instrument, but everybody can still combine these modular contents? And here you can see a plot where, for example, maybe some people use the same parameter analyzer or the same login and so on. And we thought this problem is actually screaming for modularization. So the idea of SweepMe was born to create a software where you can put modules together in a low-code, no-code environment and quickly combine instruments from different vendors to create your own measurement software. And the solution that we created looks like this. Here on the left, you can see the screen. In the left of the screen, you see the sequencer. This is the main window where you create your measurement flow by using modules. And on the right side, you see a dashboard where you can add widgets and visualize your data so that you create your own measurement software, but based on ready-to-go contents. We have a free software where everybody can start to make simple measurements for free, and one can extend the entire software with paid add-on modules, as I will also explain a little bit later on. We have shared generic instrument drivers. This means once an instrument is implemented into SweepMe, it can be used at many setups and without rewriting the code. So the code is very reusable and sustainable. And this is one of our mission at SweepMe, that we create reusable and sustainable content that can be used by many and can be shared over the SweepMe platform. To understand how SweepMe works, it is essential to understand the sequencer. The sequencer is the heart of SweepMe, where you add the modules to a tree-like program flow. And with that, you create your measurement. The idea of SweepMe that we figured out is that every measurement often consists of for loops or even nested for loops, so multiple for loops nested into each other. For example, you want to vary a monochromator wavelength and read out a login, or you want to vary a voltage of a source measuring unit and you want to read out a sensor. And these tasks are very prominent in research and development. So our software is organized in a way to make this very simple, because whenever you nest modules into each other, you automatically create nested for loops. You can see this here in the pseudocode that each module creates a for loop. And for each of the set value combinations that you create, we call the values, or we set the values first for all the modules, and then we call measurement values from all active modules in one branch. And because it is a tree-like system, you can also create multiple branches. For example, here a wafer prober goes to a certain position, then you make your first measurement, but you can then start with the second branch, also another measurement. For example, here first a DC measurement with some source measuring units, and then maybe a time-dependent measurement with a signal generator and an oscilloscope. And here you can also see how this opens up a new branch with additional for loops. So in general, SweepMe is really capable to make multi-dimensional parameter variations like position variations, temperature variations, voltage variations, and all in one sequencer tool. And this concept allows to combine easily different devices and different interfaces. So you can add instruments via RS-232 with GBIB, with Ethernet, or whatever you can control with a computer or with Python to access some data. And the structure of the sequencer allows also to add modules at higher and lower hierarchy. This means if you build such a sequencer, you can add at any time new modules, for example, at lower hierarchy. For example, you want to have now an additional temperature sensor that is read out. So you just add another module for reading out your temperature sensor, and also the data will be collected automatically. But for example, if you want to make this entire measurement temperature dependent, you can at any time add a temperature module very high into the tree, and everything is automatically temperature dependent. And this gives you a lot of flexibility to grow with your programs. For example, you can create measurement procedures in SweepMe in a bottom-up approach. This means you can start with a single SMU, and stepwise you can add more and more modules and make your concept larger and larger, or your program larger and larger, without thinking about how to structure your measured data, how to visualize it, because SweepMe will handle this in the background for you. And here you can see the gameplay of how SweepMe is used. So you go to the sequencer, you have your list of modules. You have basic modules that you typically always need somehow, like calc, delay, hold, or loop. Then you have instrument modules. These are the modules that can load instrument drivers, and we have add-on modules. You drag and drop these modules into the sequencer, and once they are in the sequencer, you get a tab. The tab is basically the module. The module is a user interface that is ready to go. You just need to configure. There's no need to program here. And in such a module, for example, here the source measuring unit module, you can select a driver. This is done here in the field device. And the driver is nothing else than a Python instrument driver snippet, code snippet, where all the commands are written in, and where you can see open source how we interface with the instruments, and where you can also create your own drivers or manipulate drivers and modify them, and how we have a certain structure that all the instrument drivers are immediately combinable with each other. So even if we did not test, you can immediately combine a certain power meter or a labs power supply immediately with other instruments or with a vapor prober, for example. So basically you add modules and then you configure these modules. And typical use cases for this are, of course, semiconductor devices. This is one of our #1 use cases now today, that people have a vapor prober and want to combine it with some additional equipment like switching matrices, parameter analyzers, or source measuring units. They can do stress tests because you can also nicely do loops in the sequencer. You can make these multi-dimensional parameter variations, of course, and can create larger test plans with multiple branches to run multiple measurements for each test site on the vapor. Another very interesting use case is vacuum deposition. And this is showing that SweepMe can not only collect data, it can also control a chamber or a system. And this is quite interesting because, for example, vacuum chambers are often very individual. It means often institutes or companies order vacuum chambers that are made, customized to their needs. And then they have different equipment, like different pressure controllers. They have maybe rate thickness monitor and temperature controller. And because each combination or each vacuum chamber has its own combination, you also need a customized software for each vacuum chamber. And here SweepMe can be very nice because you can put everything into a loop. You can read out all these instruments. You can use it also with a PID module to stabilize, for example, evaporation rates, and also start controlling certain systems in your lab. And a last use case that I want to present is solar cells, or let's say also LEDs and in general optoelectronics, where you combine electrical measurement equipment with optical measurement equipment like filter wheels, monochromators, lamps, and so on. And this is also a very popular use case for SweepMe among many others, like measuring sensors, silicon photonics, or measuring batteries, and so on. SweepMe is nowadays used by more than 100 companies and research groups, and that's actually a quite nice thing because as a platform, it is important that many users are there, and with each user, a new instrument comes into the platform, makes it more easy for others to get started, because the more instrument drivers are in the system, the less you need programming skills, and you can directly start with ready-made content to start combining it and creating your own measurement flow. Here, I want to now present some examples how to create a measurement. These are very simple measurement programs, but it's nice to show that it maybe only takes 5 minutes to create such a measurement. For example, we want to measure temperature-dependent IV curves of an LED. First, we take an SMU, and this SMU is configured to make an IV sweep. I will also show this later in my live presentation or live demo of SweepMe. Another SMU can be another channel of the same physical unit of an SMU, can be used or configured to read out a photodiode. With the current signal of the photodiode, we get the luminance value, and we have also luminance voltage curve and IV curves. So these two SMUs are already enough to make one IV curve. Because these two SMU modules are nested into the temperature module, we already have a temperature-dependent measurement, and we get already these immediately this list or this number of IV curve for each temperature. The makefile module in SweepMe has a special meaning because it decides how many files are created. The makefile module creates for each higher variation a new measurement data file. This means because temperature is higher than makefile, you get automatically a new measurement data output file for each temperature where your IV curves are saved in. Additionally, there's also the temperatures written into this file. So very simple measurement. And if these instruments are already included, it takes you a few minutes and you have the measurement ready to go. And in the next example, I want to show you how you can use the same modules, but differently configured to do a different measurement. In this measurement, this was some old research also from me that I did when I was at university. We investigated an LED and wanted to heat it up by driving a current to the LED. So we had one SMU that supplies a current, and the current is ramped up. And when the device gets hot because of self-heating, it has some interesting nonlinear effects. And to investigate them, we can now add an SMU, for example, to make a sensing of the voltage that is at the other contact. So to see the real voltage drop at the sample, we can use a completely different other physical unit of an SMU to read out a photodiode. And we can add a camera to make a picture at each current. And of course, we also need a temperature control because when the device heats up, the environment heats up. And if we want to have stable conditions for simulations, we need to conduct the heat away. So this time, the temperature module is not configured to make a temperature variation, but it is configured to keep the temperature constant and conduct all heat away to make sure we have good control over the environment. So it's again a measurement that you can configure in 5 minutes. And using the same contents again without programming, just configuring these modules in a different variation. As a last example, I will show you 3 different sequencers and how they lead to different current voltage curves, capacitance voltage curves. Here, a capacitive memory is investigated. And if you have a capacitive memory, it is typically about charges that are trapped in the memory. And depending on the history, you get different IV curves. And for example, it is very interesting to charge up the capacitive memory every time before you do a voltage sweep. This is like done here in the second row, where we get for each new sweep, we have completely fully charged up the memory, and you can see how you get more and more charges out of the device. But you can also make curves where you just charge the capacitive memory once, and then you can see with each line that you stepwise can pull out charges out of the device. And these are very interesting measurements. And again, you can combine modules and get different measurements and routines. And what is possible with SweepMe is that you can also boost the entire software with add-on modules and with SweepMe Pro. What does it mean? Is these basic modules and the instrument modules, you can do simple measurements for free. For example, you can do an IV curve for free or a temperature measurement for free, where you need these instrument drivers and basic modules like makefile or loops, or even saving the data of your measurement is possible in the free version. But if you want to make more complex measurements, like larger semiconductor vapor tests or control of vacuum chambers, you typically need our add-on modules. And with that, you get formulas, you get additional sliders, you can have additional buttons, you can run custom scripts and add your custom widgets, and you get all kind of stuff that you need to create a professional software and a professional setup. And here's our pricing overview. As I said, SweepMe as the standard version is free. You can use it for basic measurements and use all the instrument drivers that we have. You can save your data. If you have questions, please feel free to go to our forum and ask her. We are very happy about people using the forum. And in SweepMe Pro, you get then additional add-on modules. we have now Pro features. These are features that make the using of SweepMe easier and handling larger setups. And we have an included migration service where we help you whenever there are problems to move to a new version. And one online meeting per year is included, so that you can ask questions about your setup and where you can discuss new sequences and measurement routines at your setup. We also offer for larger corporates enterprise versions where you have an included support. And the advantages of SweepMe that we see is basically, of course, you can save a lot of time by not creating again and again the code that already other people wrote, because we can share instrument drivers and they are reusable. You have immediately code that you can use at multiple setups. This makes it also easier for colleagues to understand the setup and to get into a setup and figure out how it works and to expand it. SweepMe is using or based on Python. It means you can write drivers in Python, but you also get a GUI-based lab automation. And this is often a problem with Python to create a user interface because you need threading and more advanced concepts of programming. And here SweepMe helps that you can quickly create plots and visualize your data. What we basically see is that with SweepMe, people start to test new ideas. They get more flexibility to test new ideas because now when it is very quick, you go to the lab and just test it when you have a new idea. And as I said already, one software for many setups also helps to reduce maintenance costs and helps people to quickly get started. We have many or multiple sources for help and support. First of all, you can also go to our YouTube tutorials and the channel and see videos that are very similar to what I present also in the live demo, how you can save data and how you get started with your first measurements. You can at any time come to our forum and ask your questions there. And we have a wiki. And now we also developed some AI tools that you can find on our webpage, where you can ask questions and you will get help that is based on information from our wiki and our forum, for example. Yeah, this is the first part of the web seminar.